Now let's talk about curvature. Let C be a smooth curve in the plane or in the space given by RS, where S is the arc length parameter, and curvature K at S is dt over ds. So that's like the change in the tangent vectors over the change in the arc length. And they call that the magnitude. It's the magnitude of that. So the magnitude of T prime S. All right, so down below, we deal with the formulas that we're actually going to use. This one is just more of the introduction to the actual formulas for curvature. And if you look below here, they call these alternative forms for curvature. Now this first one is the one we probably use the most. The other ones, depending on the information given, I may use one of those. But take a look at this. If C is a smooth curve given by RT, then the curvature K of C at T is given by K equaling the magnitude of T prime T over the magnitude of R prime T. So this is a lot of taking derivatives here. So if you think about T prime T, how do I get T? If you forgot, T of T is equal to R prime T over the magnitude of R prime T. And if you think of those, that is just T. So I'd actually have to take this and take the derivative of it, and now I have T prime T. So that's kind of where we're heading here. So this first formula is probably the one we're going to use. But if you think about it, I have to take the derivative of RT twice in order to get T prime. Now again, I still have to divide by the magnitude, so we have to be careful and do it all in order. But that's the idea here. So in essence, we're going to take R prime T, take it over its magnitude, that's going to be T, and then take the derivative of that, and that's going to be T prime T. Let's just take a look at the other ones real quick here. So for the other one, the three-dimensional curve, then the curvature can be given by the formula. You take R prime T and cross it with R double prime T, and take the magnitude of that over R prime T cubed. Now the one above here, don't be confused. This is also three-dimensional or as well. I can just use both of these for the same thing. This is specifically for 3 dimensions because it has a cross product in there. The cross product is defined on 3 dimensions. So that's why it has to specify 3-dimensional. This could work here with 2 dimensions. So anyways, let's move on to the third one here. It says if C is the graph of the function y equals fx, and both y prime and y double prime exist, then the curvature K at point xy is given by this fancy formula. Okay, so the nice thing about this one is if I'm given an equation, then I could come up with a curvature formula for this, and I don't have to find R prime T, or RT I mean, to get R prime T and then R double prime T. So that's the nice thing about the third formula. So this one comes in handy here and there, but probably the least, but can be used. Anyways, let's get down to the problem below here. It says find the curvature of RT being 2 sine t, 5t, 2 cos t. So what we're going to do is we're going to find the curvature of this one, and we'll use the top formula. Now first we can find R prime t because we're going to need that for t anyways. And I just put that formula in there so we could see it. So R prime t is going to be 2 cos t, comma 5, comma negative 2 sine t. Okay, so that's going to be my R prime t. And I also need to know the magnitude of R prime t. So then I take the magnitude, and I'm just going to get this from the last video. So R prime t, the magnitude is actually going to equal the square root of 29. I don't want to go through it again. If you're curious, go back to the previous video. You'll see where I actually worked it out. Okay, so those are the 2 pieces of information I need. Now I have t. So my TT equals this here. 1 over square root of 29. The vector 2 cos t, 5 negative 2 sine t. Now we have to take the derivative of this thing here. So we take this derivative, which is going to be the derivative of this. So I just kind of wrote that out there, the 1 over square root of 29. And that's going to be negative 2 sine t, comma 0, comma negative 2 cosine t. So there we go. So now if you look at the formula, I actually found this here, the r prime of t. Now I have to take the magnitude of it, and the magnitude of that's going to be the top. So what is the magnitude of t prime t? That's what I'm finding now. So that's going to be 1 over square root of 29. Don't forget about that. It's easy to do. So remember, instead of doing the square root of 1 over square root of 29 in that, just pull it out and do the norm before it and then multiply it back in. The norm just means the magnitude, just in case you were curious. So this is just going to be the negative 2 sine t, 0, comma, negative 2 cos t. And then when I do the magnitude of this here, this is going to end up giving me 4 plus 4. I don't really want to show all the work for that, but just realize I'm going to get a 2 on top. And when I square those, the negatives go away. So I'm going to actually get 1 times the square root, or 1 divided by the square root of 29 times, and that's going to give me 2. So now this is going to give me 2 over square root of 29. Now the last step here is I got to take this magnitude of t prime t, which is on the top of here, for curvature, and then I have to divide it by the magnitude of r prime t, which I already have down here. So this curvature then is going to equal 2 over square root of 29 over square root of 29. Which actually gives me, because I end up timesing those square root of 29s together, it's going to give me 2 over 29 for curvature. So there's our answer for this one here. So now go through the math, make sure it works out for you, and if it doesn't, get a hold of me. So there's our answer for curvature.